Welcome to the 7.4 notes. This one's going to be a little bit longer just because there's a lot of pieces going on. What we're going to be talking about is the graph of a rational function. And before we get into all of this, I just want to say these are the rules. You're going to want to look back at this section at some point in time. I tried to keep it as simplified as I can, but rational graphs have a lot of pieces going on. So before we get into how we find these pieces, I just kind of want to say that there are these two dotted lines like this and like this. Those are called asymptotes, which I know is a funny word. It sounds funny and it kind of sounds like a cuss word. The vertical asymptote, I'm going to call that VA most of the time. So whenever you see that in the notes like this, that stands for vertical asymptote. And that is this line right here. That is the vertical asymptote because it's vertical, it's going up and down. And what it is it's sort of like a boundary line or almost like a magnet that repels instead of attracts, where this line is going to get really close to it, but it's never going to cross over. So it just kind of goes parallel to it, kind of like hovers near it. And there's another one called the horizontal asymptote, and it's HA. H is for horizontal. And it's the same idea, but it's going side to side. So like this graph right here is sort of stuck in between these two. Then we have pieces that we've done before, and that is the x-intercept is right here. And the y-intercept is right here where it crosses the y-axis. There we go, that's a little nicer. And then you'll notice that there's this kind of funky part right here. That is actually called a hole. So there's literally going to be a hole in the middle of your graph. And that's the first thing that we're going to actually start talking about over here. So first thing is you've got to factor first. If you haven't gotten onto that this unit, I don't know where you've been. Then everything kind of falls into place afterwards. So if there are any factors that cancel out, the zeros of those factors are what cause the hole. So since they're not in the problem anymore, they sort of just go away. But when they go away, they leave behind a hole. A vertical asymptote occurs because you can't divide by zero in math. So basically, this is a value that x is not allowed to be. But it's not just a hole that got taken out, it's something that would actually make the problem incorrect. So anything that makes the denominator 0 is a vertical asymptote. And then we have our x-intercepts. And if you want to find the x-intercept, that means that you have 0 equals the whole thing. Okay, and I'm just going to say 0 equals, just say x plus 2 over x plus 3, for example. The x-intercept means that y becomes 0, so you would want to figure out what makes this whole thing 0. It turns out you actually don't care about the denominator, because if this turns into 0, doesn't matter what goes on bottom, 0 divided by anything is 0, so you're really just setting the top part equal to 0. And then the y-intercept is always the same for any type of function, no matter whether it's simple or complicated, you always plug in 0 for x. And then lastly, there's the horizontal asymptote. I'm going to talk more about this when we get to an actual example, but it is based on the degree, or the highest exponent. If the numerator has a lower degree than the denominator, then it's y equals 0. If the degrees are equal, then you just divide the leading coefficients, but it's still y equals. And if the numerator has a bigger power or a higher degree, then there's just none. And I'll talk to you about all three of those as we go through examples. These all make a little bit more sense once you start seeing them. Alright, so I'm going to start with this first example, and I'm going to factor it first. So I'm going to start with the top, and I see that there is a 2 in front that I can't divide by. So I know I have to split the middle into two numbers that multiply to -2 and add to -1, which is -2 plus 1. So I keep these two parts the same, boom, and in the middle I split it up between two numbers that multiply to -2, add to -1. And then I'm going to factor by grouping. So I'm going to group these two together, and I see that I can divide them both by 2 and x. So that's what goes in front of my parentheses. 2x squared divided by 2x is x, and -2x divided by 2x is -1. Then I do the same thing but for these two. And nothing really goes into both of them, so I'm just going to put a 1 outside and keep it the same, x minus 1. And then this whole thing now has a GCF of x minus 1, so that goes out front. And then in the parentheses, you write what you have left. Well, if we took the x minus 1s away, I have 2x plus 1 left. And those are my factors of the top part. Now I need to worry about the denominator. And I need two numbers that multiply to -12 and add to -1, which is -4 and +3. So it's factored. I know that took a while, but that's honestly the hardest part. Everything else afterwards you can almost do in your head. So I'm just going to kind of go down this list. Okay, the first thing that I'm going to look for is the x-intercept. That means that this part right here equals 0 because we want this whole thing to equal 0. And I'm going to kind of write that over here. Like that. I know it's kind of small, but you just want to set the top equal to 0. So that's going to be two answers, 1, and this one is going to be -1 divided by 2. So 1 and -1/2 on the x-axis because those are my x-intercepts. Once again, x-intercepts means you set the top part equal to 0. The y-intercept is where you plug in 0 for x. Okay, so you basically just replace x, 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 and x with 0, which turns into -1 times 1 and -4 times 3, -112, which just means it's some really small decimal, but it's basically 0. I can't even draw it very well because you can see it kind of connects the points already. And then we're going to do the vertical asymptote and the horizontal asymptote. The vertical asymptote is because you can't divide by 0. So you need to find the zeros of just the denominator. Which would be 4 and -3. So we're going to go draw a vertical line at 4 and -3. And then we get to the horizontal asymptote. The horizontal asymptote is where you compare the degree. So the highest exponent. I have an x squared on top and an x squared on bottom, so they are equal. Since they are equal, it's y equals the leading coefficients being divided. Don't let the phrase leading coefficients mislead you. It's not that hard. It's just these two numbers right here. That is the horizontal asymptote. So notice how, though I went back to the original, I did not use this right here because you can't see the degree and the leading coefficients from the factored form. It's the only thing you actually want the original for. So that's going to be at 2, which is a horizontal line at 2, like that. And I'm actually going to go fix one little thing really quick. This was actually 2 negatives being divided. I'm going to change that to a positive. So it's up here just a little bit instead of down. The reason why I'm switching that is because I'm going to draw part of the graph. Okay, so I was trying to get rid of some of that, but my whiteout's not working super well. And okay, so holes. There's nothing to cross out on the top and bottom, otherwise we would have done it. So there are no holes. And we'll do the domain and range in just 1 second. We're going to go ahead and draw the graph now. These 3 points are kind of in an arc. That's because it's going to get really close to this side and really close to this side. But it can't go up because it's got to stay in this area. These asymptotes have made us a boundary. And then over here, I'm going to take my calculator and plug in any number that's on this side so that I know where to put my graph. So like I'm going to pick 6. And I'm just going to plug it in 6 minus 1. And 2 times 6 plus 1. Oops, I typed 11. Okay. And on the bottom, I have 6 minus 4, 6 plus 3. 65 divided by 18. So I just did the top, the bottom, and then divided my 2 answers. So that means I go over to 6 and I go up about 3.6. And there you go. And then I need to do the same thing, but with a number from this side. Since I picked 6, I'm just going to change that number to negative 6, because that's on the other side. So I get 77 divided by, the other side is going to be 30, which is 2.6 basically. So I go to negative 6 and up 2.5, which means this one goes like this. See how it's kind of like going along the bottom and then it's going along the top. It can't cross these lines, it just kind of goes parallel to them. And then we're actually going to wait for domain and range until next week, so go ahead and cross those bad boys off. You'll be able to do the same thing on your assignment. Whew, okay. I promise you it gets a little bit easier as you practice more, but this section definitely takes practice, so make sure you actually do your assignment. Up here, I just need 2 numbers that multiply to negative 28 and add to 3. 7 minus 4. And on the bottom, I need 2 numbers that multiply to 35 and add to 12, which is 7 plus 5. And you will notice that there is an x plus 7 on the top and on the bottom. What that means is they cross out, but behind they leave a hole at negative 7. So notice how in my notes I said that it is the zeros of factors that cancel out. The 0 assigned to this factor is negative 7. It's always the opposite. Then we're going to have to fill in the rest of the hole by finding out how high to put the hole. Because we know it's over here at -7, but we don't know if it's up here or down here. All you have to do is plug in -7 to get the rest of it. But not into the whole thing, just into what's left. So -7 minus 4 over -7 plus 5. Notice where I put my parentheses, because if I don't use these parentheses, my calculator is going to do it in a weird order. Sorry, there. You don't need the last one. 5.5. So what we're going to do is go left 7, up 5.5. 2, 3, 4, 5.5. And put a open circle there, because it's a hole. It's not a regular point. And then we're going to move on to everything else, and now we can just completely forget that that x plus 7 was ever there. X-intercept is where you set the top part equal to 0. That's 4. So go put an x-intercept at 4. The y-intercept is when you plug in 0 for x. So we have 0 minus 4 over 0 plus 5, which is -4/5. Didn't make my mistake on the negatives that time. So that's almost -1. There you go. Vertical asymptote is what makes the bottom part 0, which is -5. So I'm going to go to where x is -5 and draw a vertical line. It wouldn't make much sense to draw a vertical line through the other -5 on the y-axis. The horizontal one is where you have to go back and look at your notes. So I have x squared over x squared. That's equal, so you just divide the leading coefficients, which there really aren't any. They're both really just 1. So it's going to be at y equals 1. And you can write x equals on the vertical one if that helps you remember. X-intercept and vertical asymptote both involve x. The y-intercept and the horizontal asymptote both involve y. So then I go to where y is 1 and draw my horizontal asymptote. Like that. And then again, we're skipping domain and range. So now I just need to try and draw my curves. I'm going to draw one over here through both of these points. Remember, it gets parallel to this one, and then it kind of curves around and gets parallel to this one. And this one gets parallel to this side, and then it kind of curves down and gets parallel to this side. Just like that. Much easier if there's only one vertical asymptote, but it is possible for there to be multiple. Alright, on the next one, we only have to factor the bottom because the top part is fine the way it is. Two numbers that multiply to 20 and add to 9. 4 and 5. And then guess what, guys? We get to cross off the x plus 5s. Remember, it can only cross off if both sides of the fraction have x plus 5 together. And then just going to leave behind a 1 on top. I call that a hanging fraction. If you don't leave anything up there, you got to leave something. Okay, x-intercept, you set the top part equal to 0. Can 1 equal 0? No, so there's no x-intercept. And I'll explain why in just a second. Then, for your y-intercept, that's where you plug in 0 for x. That's 1/4. Okay? Then, vertical asymptotes, where you set the bottom part equal to 0. That's going to be at -4. Because you just subtract the 4 to the other side. Just remember that that's not a point, it is the dashed line. Horizontal asymptote is where we compare the degrees. On top I have an x, and on bottom I have an x squared. So the top one has a smaller power. And whenever that happens, it's just y equals 0. Which will make sense because when we go to put our horizontal asymptote at y equals 0, it is on the x-axis. So it couldn't have had a y or an x-intercept because that's where this line that it's not allowed to be on is. And then let's go to our whole. I crossed off an x plus 5, so it's going to be at -5. And then I plug in -5 into the equation. -5 plus 4 is -1, and 1 divided by -1 is -1. So I'm going to go left 5, down 1, and that's where my hole is. Again, we are going to skip domain and range for today. We will talk about it, just not yet. Okay, so I've got 2 points, one's here and one's here. So that tells me that instead of being in these two corners, it's going to be in these two corners. Draw my line and curve it on up to the vertical asymptote. Ta-da! Very last part is we're going to practice writing some equations. We want to write the factored form of a rational function with a vertical asymptote of x equals 5. Remember that the vertical asymptote comes from the bottom. So if I want the bottom part to equal 0 when x equals 5, it needs to have an x minus 5. And if it has a hole at x equals 1, the same way this one had a hole at -5 because it was on top and bottom, it would have an x minus 1 on top and bottom. That's it. Over here, it wants us to write the standard form of a rational function with a horizontal asymptote of y equals 4. Let's go back to our horizontal asymptotes. This one's y equals 0, so we can't have this one. This one doesn't even have one, so it's not C. And for B, the degrees have to be equal, but the number is the leading coefficients being divided. Like this one was 2 over 1, so it was 2. So if we want ours to be 4, we should probably have a 4 on top and a 1 on bottom. And then I just need to write something that has the same degree. The rest of it is up to you. That could be fine, or you could do this. You can add whatever you want afterwards, but this is the most important part, that this is 4 and this is the same number. So you kind of have to work backwards and go back to this and think about it the other way around. Okay, make sure you keep track of these notes, or you have a picture of it on your phone or something like that. In fact, I will move my hand out of the way so you can take a picture of this screen now if you would like.